Hello, this is Ms. DB, and we are going to continue our work with Chapter 13. This is Section 3 on the unit circle. So our objectives today are to convert angle measures, which we've been using, in degrees. We're going to start to convert them to radians, and then we can convert radians back to degrees. So go back and forth between the two. It's just a simple little formula. And then also we're going to find the values of trig functions like sine, cosine, and tangent using something called the unit circle. These are kind of fun. All right, so like I said, so far we've been using degrees, and probably up to now you've only dealt with degrees like 30 degrees, 60 degrees, and so on. Now we're also going to switch over to radians. And as you get into more advanced math, you'll find that radians is kind of the standard that is used, which is why if you're using a TI-83 or TI-84 graphing calculator, the default is radians, because in pre-calculus, calculus, and beyond, radians is kind of the basic standard that you'll be using. So it's good to know how to go back and forth, and it's good to know to start thinking in radians as well. So radians is a unit of angle measure based on arc length. From back in geometry, arc length is just a section of the circumference of the circle. So if we have an arc length from here to here, that's 1 radian. So if a central angle theta in a circle of radius r, the measure of theta is defined as 1 radian. Okay, so here's what we got. We've got that if we have an angle of 180 degrees, that's equal to pi radians. This is the key right here that we are going to base our conversion back and forth on that. It's 2 radians if you go all the way around the circle, or 2 pi radians. It's just pi radians if you go halfway. So a complete circle again is 2 pi. Half a circle is pi, and we're going to use that fact to go back and forth between the two of them. Here's the key. If you are asked to go from degrees to radians, like 30 degrees to radians, you want to multiply by this unit of measure that has 180 on the bottom so that your degrees cancels with degrees. And this would be pi radians then. So it's pi over 180 or 180 over pi, depending on if you're moving from radians to degrees or degrees to radians. So if you're starting with degrees, then you want the one with 180 degrees on the bottom. If you're starting with radians, then you want the one with the pi radians on the bottom, because then the radians cancel with the radians. When they talk about angles measured in radians, there won't be a degree sign. So if there's no degree sign, then assume that it's radians, especially if there's a pi in it. All right, so here we go. We're going to go from degrees to radians and then radians to degrees. So since we are starting with degrees, remember the conversion is that pi radians equals 180 degrees. So you have to decide, do I want the one that's 180 over pi, or do I want the one that's pi over 180? Pick the one that you can multiply by and cancel the unit of measure. So in this one, we want to cancel the degrees, so we're going to multiply by pi over 180. And then you just simplify after that. Let me erase that so we can see what they wrote. And simplify carefully. Once you pick the right unit of measure, we are going to simplify. Here we have negative 60 on the top, on the numerator, and 180 in the denominator, and 60 over 180 simplifies to 1/3. There was a negative on our original problem, so we need to keep that negative. There's still a pi left after you cancel, and it's just going to be negative pi over 3 radians. The second one is already in radians, so we want to convert that to degrees. So for our second one, we're going to multiply by 180 over pi. So we write down, and you don't have to write radians every time. If I was doing this, I would just write 2 pi over 3 times 180 over pi. Now when you multiply, the pi's will cancel. Oops. And you should end up with your answer is going to be in degrees. So we have 2 times 180 divided by 3. Or you can cancel first. You can say, well, 3 goes into 180 60 times, so 2 times 60 is 120 degrees. So remember that if you're going to degrees, that you put a degree sign on your answer. If you're going to radians, you could just write negative pi over 3 or write negative pi over 3 RAD for radians or spell out radians. Okay, here's just some more examples. In this first one, we're going from degrees to radians, so we're going to multiply by pi over 180. So we're going to multiply by pi over 180. Now this one's not going to simplify as far as the other one did, but I can simplify a little bit because pi over 100 or 80 over 180, at least that much cancels. Then you'd have 8 over 18, but 2 goes into both of those, so then I would have 4/9 pi. Or you can write that as 4 pi over 9. The second one is in radians, so I'm going to multiply by 180 over pi. And again, you don't have to write the words radians out every time. You can take 2 pi over 9 times 180 degrees over pi. And again, the pi's will cancel. There's 1 in the numerator and 1 in the denominator. We can simplify this, or you can multiply first. This would be 360 over 9, and 9 goes into 36. So this was 40 degrees. Make sure you put your degree sign on or write degrees when you are going to end up with an answer in degrees. If you're using Word to make that degree sign, you could make like an exponent and then put a 0 or an O. That looks a lot like a degree sign, or you can go to the symbols menu and find the actual degree sign. I kind of often will just use that exponent with the O, little O. This is just more examples. You can try this on your own and then check and see how you did. So for C, you should have got negative pi over 5. And for D, you should have got 720 degrees. So our degrees can be greater than 360. All right, here's some problems from your worksheet. And on some of them, I have what you're going to be multiplying by to change. So in the first ones, we're changing from degrees to radians. So I'm going to be multiplying pi radians over 180 degrees. So let's do number 3. I'm going to be multiplying this by pi over 180 degrees. So the degrees will cancel the units. So I have 210 over 180 pi, and we need to simplify this. So I can divide them both by 10, which just cancels the 0. And then let's see, they're both divisible by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. And don't forget to write the pi. Now this is in radians, so it's probably a good idea at first to at least put your write radians after that. And number 4 has a negative 120, so make sure that when you multiply by pi over 180 that your answer will be negative. And then figure out what 120 over 180 is, and then put the pi. Don't forget the pi or it's wrong, and that'll be radians. You still need to simplify this one. You could divide both of them by 60, maybe even, yeah, 60 would work. Okay, and then on the second part, 5, 6, 7, and 8, we're going to be changing these 2 degrees. So we're going to take the pi over 6, number 7 here, and we're going to multiply this time by 180 degrees over pi radians. So when you do this part of the worksheet, the pi's will cancel. And then you're just going to simplify what's left, and your answer will be in degrees. So you figure out what 180 divided by 6 is. 6 goes into 18 3 times, so this is going to be 30 degrees. This is one to memorize, that pi over 6 radians is equal to 30 degrees. We see this one all the time. And it's nice to start to memorize the conversions in your head so that when you see it in radians, you can think degrees or vice versa. All right, next we're going to talk about a unit circle. A unit circle is just a circle drawn on the coordinate axes with 1 as its radius. 1 unit is its radius. So this is 1, this is 1, this is 1, and this is 1. And the coordinate points at that point are written here. So here we have that this would be the point 1, 0, of course. This would be 0, 1. This one is negative 1, 0, and this one is 0, negative 1. Now, it turns out that you can put these very common special angles on the unit circle, and we can use this as a shortcut, a very handy, nice shortcut to find the sine, the cosine, and the tangent of certain degrees. And the unit circle, very conveniently, is labeled in both degrees and radians. So here's that 30 degrees and the pi over 6. There's the degrees on the inner circle. And here's the radians listed after that. So these are the radian conversions of the ones we just looked at. And it so happens that we can find that the sine of an angle is going to be these red points here. So written in red is the sine of 30 degrees. The sine of 30 degrees is 1/2. Well, the sine of pi over 6 is also 1/2 because it's the same measure. It's just written in two different forms. The cosine is going to be the blue here. The first one's listed. The x-coordinate of each of these points is the cosine. Now, tangent's a little bit trickier. For tangent of these angles, you have to take the red over the blue. So you have to actually figure out the tangents. So it's very nice that this is cosine, sine, but for tangent, you have to do the y over x, the y-coordinate over the x-coordinate. So those ones are a little bit more work. But cosine and sine are super easy and fast to find. And you can even convert between radians and degrees by looking at the unit circle. So this is something that you want to print. It's on your worksheet. You want to save it. You want to refer back to it often. There's questions on your worksheet that you'll be using this to answer, and it's nice to have it in front of you rather than flipping back and forth between pages. So learn the unit circle, and you will continue to use this in pre-calculus and in college algebra and calculus and your math beyond. All right, so here's some examples of how we'll use it. What we're going to do is try to figure out what is the cosine of 225. Now you can type that into your calculator, but you're going to get a decimal version. And this is asking you to find the exact value. Exact value means it'll probably have a square root in it. And we're going to use the unit circle to find exactly what that is. So look, here's 225. So we go around the circle till we find 225 degrees. Now the cosine is the first coordinate listed, the x-coordinate of right here. Right there is your answer. All you have to do is find it. So we find where that angle passes through, and then we just pick the right part of it, and we say that's our answer, negative square root of 2 over 2. You have to write out that I don't want you to say negative 0.707 here. You write the exact value is going to have a square root in it. And here's how you write square root. If you're typing, you would write negative square root of 2 over 2. You would just type those symbols like that. Here's another one. This one's the harder one. Tangents are harder. Okay, so first we find, this one's in radians, we have to find 5 pi over 6. So you go over, here's pi over 2, here's 5 pi over 6 right here. Now we need both of these values. Tangent is equal to the y coordinate over the x coordinate. So you write 1/2 over the square root of 3 over 2. 1/2 over the square root of 3 over 2. Now there's two ways to simplify this, and I've shown this in other videos. You can take the top fraction divided by the bottom fraction, which means to multiply by the reciprocal. That's what they're doing here. Or you can multiply top and bottom by the common denominator. This is going to be quicker in this case because 2 is the denominator of both of them. So we get a fraction of 1 over negative square root of 3. Now this is not considered simplified because we don't like to leave a square root in the denominator. So we do what's called rationalizing the denominator, which is multiplying top and bottom by the square root that is in the denominator already. And 1 times the square root of 3 is the square root of 3. In the denominator, the square root of 3 times the square root of 3 is 3. Now, it doesn't matter where your negative is. You can leave it in the denominator. usually you will see it written just in front of your fraction. And again, if you were typing this, you would write negative square root 3 slash, for the division sign, 3. And that is the tangent of 5 pi over 6. Now again, if you type that into your calculator, you're going to get a decimal version. That is not the exact value, which is what we're looking for in these problems. We're using the unit circle to find the exact values. Now let's say that you've already memorized the right triangle, special triangles. Maybe you know that sine of 30 is 1/2 because you did those right triangles in geometry and in the last couple sections. So here's what you're going to do. You're going to sketch that out on your coordinate system. You can use the quadrant 1 of the unit circle to find the sine, cosine, and tangent of the reference angle, unless you already have them memorized. And then you're going to adjust the signs based on where it actually ends up on your circle. So that's the signs. You can look at those, or you can just, I'm going to show you how to figure that out as you go. All right, so 330. First thing that you're going to do is draw a sketch of where that is on the coordinate system. So if you have the coordinate system, I didn't draw the y-axis on here, but remember you always start on the x-axis, and you would go, here's 90, here's 180, here's 270, 330, you end up right here. Next thing you do is you figure out the reference angle. Remember, you go back to the x-axis. I need to figure out what is this angle. Well, if I went all the way around, it'd be 360, and I stopped before I got there, so this is 30 degrees. So my reference angle is 30 degrees. Now this is where you can look at the unit circle to help you say, oh, let's see, if it was a 30-degree triangle, then what's my sine, what's my cosine? You may have memorized, hey, where did it go? You may have memorized sine and cosine. So step 2 is to figure out the sine, cosine, and tangent of 330. So the sine of 30 degrees is 1/2, which means that the sine of 330 is equal to the opposite over the hypotenuse. But this is below the x-axis, so this is going to be a -1. So the sine of 330 is -1/2. The cosine of 330, well, let's go back to our little reference triangle here. This side must be the square root of 3, because if you remember, in a special right triangle, 30, 60, 90 triangle, one of the legs is square root of 3. And I already know that this one is 1 because the sine of 30 is 1/2. Okay, so the cosine of 30, if it was just a 30-degree triangle, would be the square root of 3/2. Now, do I have to adjust the signs on this one? Well, this leg is on the positive x-axis, so this would be a positive number. And the hypotenuse is always going to be positive, so this is the square root of 3/2 is correct. Okay, next I need the tangent of 330. So I go back to my reference angle here, and the tangent is equal to the opposite side over the adjacent. So if it was just tangent of 30, it would be 1 over the square root of 3, but because that is in the fourth quadrant, this side is negative because it's on the negative part of the y-axis, so this would be a -1 over the square root of 3. And then I'm going to rationalize that denominator by multiplying top and bottom by the square root of 3. So I'd get negative square root of 3 over the square root of 3 times square root of 3 is 3. So these are the sine, the cosine, and the tangent of 330. Now you can check this on your calculator, but you are going to get a decimal version. If I type in the cosine, just for example, of 330, I get 0.8660. But it's positive, so I know I got the positive part right. If I type in the sine of 330, that's -0.5, which I can tell is equal to what I wrote of -1/2. All right, let's look at another example. We're going to find the exact value of sine, cosine, and tangent of 270 degrees. So the first step is to find where does that land on your coordinate system. And 270 is right here on the y-axis going down. So the reference angle for that is 90 degrees. It's very similar to if I had just gone straight up. And then you can look up what is the sine, cosine, and tangent of 90. And you can look on the unit circle, or you can memorize some of these. The sine of 90 degrees is equal to 1. That might be one that you want to memorize. In 270, the sine of 270 is not straight up, it's straight down. So it's going to equal negative 1. So the sine of 270 equals negative 1. The cosine of 90 degrees is 0. So the cosine of 90 degrees is 0. Whoops, sorry. And it turns out that the cosine of 270 is also going to be 0. It's like there's no adjacent side on these. So cosine is adjacent over hypotenuse. The hypotenuse is the same as the opposite side, and there's no adjacent side because it doesn't go, your triangle doesn't go anywhere left or right. And then the tangent is going to be undefined because, again, there is no adjacent, so it's like it's supposed to be opposite over adjacent, but if the adjacent is 0, then the tangent of 270 is undefined. All right, next example is in radians. So you can either convert this to degrees if it helps you, or you can look at the unit circle and find out where does 11 pi over 6 end up. Let's review how would we convert this to radians if we wanted to, if our brain is still thinking degrees, or how would I convert it to degrees? So I want to convert to degrees, so I'm going to use the conversion ratio 180 over pi. And then my pi's would cancel. And I'm doing this just for my own brain to know that this is where it ends up. And then 6 goes into 180 30 times. So I end up with 30 times 11. Hey, this is one that we've already worked with. And it's 330 degrees. And we already figured out that 330 degrees is over here in the 4th quadrant, and that this would be 30 degrees, or pi over 6. And we've already found the sine, the cosine. Where did those go? On this example. We already know what the sine, the cosine, and the tangent are. This is the same as 11 pi, what was it, 11 pi over 6? So they're going to be the exact same answers that we got on that first example that we were looking at. So the sine of, if it was just pi over 6, is 1/2, but we need to put a negative on this because it is in the 4th quadrant. The cosine is going to stay the same because the opposite side is positive, and the tangent will end up being negative as well because this side is negative. And here they did that. All right, so we are, oh, here's another example, but negative 30 is the exact same as the ones we just did. Look at it, ends up in the exact same place, so these are going to be all the same answers that we just found. The sine of negative 30 will be negative 1/2. The cosine of negative 30 will be positive, and the tangent will be negative as well. All right, so let's get to our problems on the worksheet. Here are some of your problems. I don't have all of them on here. And here I put the unit circle. You can either use the unit circle to answer these questions, or you can use a reference angle like we just did. And they're kind of related to each other, and you can work with both of them if you need to. So let's look at number 9. It says, find the cosine of 2 pi over 3. Well, as soon as I see the pi, I know this is in radians, so I use the outer parts where they're in radians, and I just look for 2 pi over 3. Here it is right here. Now, the first part of that coordinate is, this coordinate here, is the cosine, so all I have to do is say that this is negative 1/2. Let's do number 11, 5 pi over 6. This is also in radians, so you just go around until you find 5 pi over 6. It's right here. This time we are looking for the tangent. Tangents are more work. To find the tangent, you have to do the y part of that coordinate over the x part. So the y part is 1/2. The x part is negative square root of 3 over 2. Now, every one of these, if there's a fraction, the denominator is 2. Look at that. They're all 2's. So every time you're going to be able to simplify this fraction by just multiplying top and bottom by 2 and then simplifying what you have left. These 2's cancel and I get 1. These 2's cancel and I get negative square root of 3. Now you have to rationalize your denominator. That means you multiply top and bottom by the square root of 3. So on the top, I get the square root of 3. On the bottom, I have negative, so I'll put a negative in front here. Square root of 3 times square root of 3 is 3. So number 11 would be negative square root of 3 over 3. How about if it's in degrees? Let's look at number 14. That's a tangent again, so it'll be a little bit harder. We go around the circle, this time looking at the degree parts, until we find 225. It's right here. And it tells us that this is the sine if they ask, or this is the cosine if they ask you for the cosine. This is the sine, and to find the tangent, you have to take the red, the y, over the x. But look, they're the exact same thing. You can go through, if you don't notice that they're the exact same thing, we can multiply top and bottom by 2. That gives us negative square root of the 2's cancel here and here and here and here. We get negative square root of 2 over negative square root of 2. That's the same thing again. This is just going to be 1. Negative over negative is positive. Square root of 2 divided by square root of 2 is 1. It's the same exact thing. If you have the same thing on top and bottom, it's 1. The reference angle is 45, and the tangent of a 45 degree is 1. So the tangent is 1. You might want to take your unit circle, and as you find some of these, write down what the tangent would be for each of them. It might be helpful. So the tangent is 1 on this. Now, it says that you could also use a reference angle. So what would that mean? Let's do number 13 with a reference angle. Okay, so that means you sketch a coordinate system, doesn't have to be fancy, and I want to go around the circle 5 pi over 3 times. 5 pi over 3 times. Where do I find 5 pi over 3? Way over here in the 4th quadrant. It's equal to 300. So I can convert to degrees, or I can just look at the radians, and I'm going to go all the way around till I get to 300. If I went all the way, I'd get to 360, so this is a 60-degree angle, or that's the same as pi over 3. And now I'm trying to find the cosine of this. So I could say, okay, if that's 60, here's 60 as well. The cosine of 60 is 1/2. That means that this should be a 1, and this should be a 2, and there's the square root of 3 over here, because the cosine is adjacent over hypotenuse. So the cosine of 5 pi over 3 is going to equal 1 over 2, and then I just have to double check if I need to put a negative on that. Let's see, the 1 is positive on the x-axis, and the hypotenuse is always positive. So I didn't use the square root of 3 part. If they had asked me for the sine of 5 pi over 3, then it would be negative because that's below the x-axis. That's negative on the y-axis. So cosine of 5 pi over 3 is 1/2. And of course I could also get that by going all the way around and finding on the unit circle that the first part is the cosine and it is equal to 1/2. Okay, I think that's it for today's lesson. Remember to print out and save a copy of that unit circle. It'll help you a lot in answering these questions. Thanks a lot and have a great day. Let me know if you have any questions.